So hey guys, welcome back to today's another video. Today we have given this question, Leetcode 2375, construct the smallest number from TI string. Let's read the question description and understand the question better. So we are given a zero index string pattern of length n consisting of characters I meaning increasing and d meaning decreasing. Okay, so the string contains two characters, basically I and d, where I means increase the number and d means decrease the number, right? So a zero string for n plus 1 is to be created, where digits have to be between 1 to 9, and if the pattern of I is if the pattern of I is capital I, then the number of I plus 1 must be greater than the previous number, and else if it's d, then it should be greater than less than the previous number, right? And we have to construct the lexicographically smallest possible strings, right? So let's say first of all, this question is quite easy if you know backtracking, right? So let's understand this problem further, right? So let's say we are given this string I and d, right? And then what do we have to do, right? So let's say I create a variable. I have just a minute, right? So let's say my number was 1, then it encounters 2, right? Then it encounters 2, then it should be 2, then it encounters I. Sorry, I was saying 2, then it encounters I, that means the number should increase, then it encounters I, then it means the number should increase, then it encounters D, that means the number should decrease. However, notice we cannot maintain any 2, right? So because it says we have to use any digit at most 1, so we cannot use 2 again, right? So what do we need to use? So we cannot use anything less than 2, so we have to increase its count to 2, 4, and then we can use 3, right? So this strings becomes my lexicographically smallest string, right? And one more thing to notice in this question is it is given that the pattern's length is 8, right? It's very important to know for this, otherwise there might arise cases if the string length is greater than 8, that when our answer is not possible, right? So let's see how we can solve it. So first solution is a typical brute force solution, right? So the first way of solving is doing a brute force solution. Why I'm showing a brute force solution? In brute force solution, I will generate all the possible substrings, right? All the possible, right? So I know that I have to create, right? I have to create an n number. Just a minute. So I know that I have to create an n uh, uh, I have to create an n sized string, right? An n sized string, and I know that each character at each place I can put, right? At each place I can put n 1 to 9 characters, right? So there's total of 10 possibilities over 1 to 9 character. That means there's total possibility of 9 character at first place, then again 9 character at first place, then again 9 character at third place, then again 9 character at third, and this will go on till all of these n position, right? So if my string contains n character, then in that case I have to generate all the 9 to the power, right? All the 9 to the power, total of 9 to the power n possible combination for a string of length n, and then I would have to check which is the lexicographically smallest, right? And to check and which of the strings satisfies the given string, and then I have to check which is the lexicographically smallest, right? For checking this, all those string takes O of n time, and doing or for all those 9 to the power 10 strings takes a total time complexity of big O of 9 to the power n multiplied by n, right? So this is obviously too much complexity for us, and we will look how we can optimize it, right? So my second solution is doing a recursive backtrack. Second solution is backtracking, right? So how we are gonna do the backtracking, right? So as doing a backtracking plus greedy, right? Backtracking plus greedy actually, and this should be C, right? So why I'm saying backtracking and greedy, so notice when I was just a minute, just let me delete this stuff, right? So notice when I was creating this array, I had option, right? I had option to I can put any value ranging from 1 to 9 over at this place, right? At this place, but I need to generate the lexicographically smallest string, right? So it is preferred to, instead of generating all those 9 to the power n cases, I will start by saying, okay, this place contains 1. What if this index was 1, right? Then I would check if then I would check for again other sub cases for other examples, right? Do following the given string pattern. And if in case if I don't found a pattern, I would say, okay, what if this index contain 2, right? In this, doing this way, I maintain the order, and I maintain an order in which the strings are formed lexicographically, right? And the strings are formed lexicographically. For example, let's again take that example which I was taking earlier. For example, IIND. So we know that for a string of length n, we have to the character for a string of length n, the number of characters will be n plus 1, right? So let's say first I create a 1, right? Then it will go into the other case. Okay, let's say it could be 1, right? So it follows the character, it says I, so the value should be 2, right? Then it follows the value, it should be 3, right? Then it follows the value d, then it see we cannot put d and 2 and 1, or nothing is empty over there. So I would increase its count, right? I would increase its count, and then it would say, okay, I can put a 3 now, right? So we have found a case over there. But let's say if it was d, right? If it was d, then it would put initially 1, right? And it would put initially 1, then it would come to the next case, right? So it would say I have to decrease 1 now, but we can't decrease 1 because 1 is the last maximum value. So it would backtrack, right? So it would backtrack and say, okay, what if d was 2, the value before d was 2? Then it would say, okay, I can now decrease it, right? Now I can decrease it, increase the increasing variable, right? Increase character, then it would increase the count. Then it says, okay, I cannot do the 3, but I can do a 3, right? Then it says a decrease, right? Then but I cannot decrease further from 3, right? So it would in backtrack, and it would say it is 4, and then it would say 3. Now also notice that the optimal solution, right? The optimal solution will also contain the numbers ranging from 1 to n plus 1, right? There's no sense in using 5 if there's only 3 characters, right? That's why I was also saying that the string length is important, right? So the solution is backtracking plus greedy solution. Let me just show you the code and how. So I have coded the solution. Here you can see I'm creating an answer variable which will store my final string, right? My final answer string. And I've created a boolean used array, right? I've created a boolean used array so that I can know that which element I have used, right? So for example, if I was saying like I have to create 1 2 3, and then I was encountering a d, right? For the example, what I'm trying to say is for the string iid, right? Iid. So I was encountering a variable where I had to again use due to the d, right? But I cannot use 2 again because I have used 2 earlier. To know that which values I have used, I'm creating a boolean array, right? Now I say, what if I right, the array is this arrays dot fill is marking the array false again for the next possible backtrack case, right? Then I say, okay, I have used that variable, and I append that character to the answer string. I'm doing a typecasting for the character over there, right? Then I do a recursive call in which I pass the starting value, right? Which is my starting value in this case. In this case my starting value was, just a minute, my starting value was 1, right? So I passed the 1 as my starting value, I passed the pattern, I passed the use, and I passed my final answer string, right? Then I have a recursive call over there. Let's see how the recursion works, right? So the recursion basically works the same. I check for all the values, right? I can put values between 1 and 9. I check what will be the next value, right? So if the value is, let's say we increment by 1, right? In case I would be 1, right? So if the character contains an I character, then I would increase, otherwise I would decrease by I value, right? And if it is within bound, if it is not within bound, then I would continue for the next case, right? But if it is within the bound, I would say if and I would again do a check if this value hasn't been used earlier. Now I would mark this value as true, append that character into the string, and I would again do a recursive call. In case by doing some my pointer reaches the last, right? My pointer reaches the last index of the string. That means I have processed all the characters, right? In that case I would return true, right? This is the base case for the recursion. And if I found a case in which I have processed all the characters, and this is one of my, then this is my answer. And also because I was doing a greedy approach by starting from the smallest integer, right? I was starting from the smallest integer, then I don't need to check for the further cases, right? Because I already found the lexicographically smallest string. Then in that case I would just return back. But in a case where I don't find it, I would just backtrack, right? I would just backtrack. I would delete character, the last appended character, and would mark that I haven't used that value, right? So So my callback comes to here, and it would say, okay, I found a valid answer, and I would just return that to the answer. And also, but in case if I don't found the answer, I will just backtrack. This is backtracking code where I just mark the value is not visited, and my delete the last appended character, right? And I've also added this condition to return -1 in case if there is not a possible answer. But we know that under given constraint where the a is less than 8, we will always find an answer, right? So this is the basic recursion code. I have ran this code. Let's run this code, right? Run this code and submit it, and it got submitted, right? No problem with that. Now let's talk about the time complexity of this problem. What would be the time complexity of this problem? So you can see I am generating, I'm taking the first value, and after that I have option to generate the next, and I can put any value between 1 to 9, right? I can put value 1 between 1 to 9 for at any places, right? So overall time complexity would be basically what I'm trying to say, at each position I would have an option, right? At each position I would have an option. I can either put n characters, right? In your case, just let's say d, right? Let's say k, right? I can put k character, right? I can put k character, right? Then I could have put k -1 character, right? Because I have already used one character, right? I have already used one character, right? Then I can use a k -2 characters only because I have already used one character, right? Basically what I was trying to say, because of the given constraint we can use only at most one character. So my recursion is going to be like that: at first place I can put 9 characters, at second place I can put only 8 characters, then only 7 characters, then only 6 characters, then only 5 characters. So you know this type of complexity would give a time complexity of overall 9 factorial. So by doing a backtracking plus greedy approach gives an overall complexity of 9 factorial, right? That's the answer, right? However, there's one more optimal solution, right? There's one more optimal solution which solves the problem. There's one more problem, right? There's one more solution, optimal solution using stack. Now it's quite not intuitive to come down at stack, right? The brute force one is quite intuitive, and the backtracking one is also quite intuitive, but the optimal solution which includes stack is not that intuitive. Let me explain why I'm saying not that intuitive. Just let me take a bare string, right? Let me just take this example, right? So not just like that example, let's form our own example, right? So let's say I have to insert I and I, then I would have to insert a D, then again a D, then again a D, and then again an I, right? So what would you do, right? What would you do in that case? So I would say, okay, let's say I have put a 1 over there, then I would encounter I, right? And I would encounter I, so then I would say, okay, increase the count by 2, then I would encounter I, then I would say, okay, increase the counter by 3. But as soon as I notice the D variable, right? As soon as I notice the D character, I say I have to decrease the count. Then I would go back and I would say, okay, just reverse the characters, right? Just decrease last one, right? But we don't know future. We might again need to update these values, right? Then again we encounter a D. We say, okay, now we again need to remove these two, right? To make the lexicographically larger string, smallest string. Then we again encounter a 1, right? Then we again encounter a 1. D, right? So I have to again go and do this, right? Then I again have to go and do this, right? No problem with that. No, actually just do this, right? I say I will put a 1, I will put a 2, right? But just let me do what I was trying to say. But now you would say, but doing so the ith sequence has been disrupted, right? So you would say the only possible way for the solution to work is that if we consider some another character over there, right? Like let's say I consider the character 6 and then 7, and then I would have to decrease it to the 4, then only it would work, right? Because after that I can do it as 8, right? So but that's not the optimal solution. Why I'm saying that's not the optimal solution? Instead what I could have done is I could have done 1 2, just a minute, I could have done 1 2, and after that count the number of D's, right? Count the number of D's. So and also you would notice that whenever there is an I sequence, the numbers are increasing consecutive. We can put consecutive numbers increasing, but whenever there is a D sequence, the number are decreasing consecutively, right? So what I'm trying to say, the optimal solution for this problem would be, so I would have to put a 3, a 4 and then 3, right? Up 4 3 4 and then 3. Just put 3 over there, right? And then I would have to put a 4, right? So I would say, okay, I just put a 5, what I'm trying to say, the answer would for this would be, right, I would say okay, I would just do this 4 and 3, then I would say okay, I have to update another value, then I would say okay, 5 4 and 3, right? You would notice this case also follows what I'm trying to say, right? Then again I would have to update it as 6 5 4 and then 3, and then finally I can update this value to 7. You notice what I was trying to say, right? I hope you got what I'm trying to say. So basically whenever we encounter a d, we just have to reverse the numbers, right? We have to reverse the number and push it. So how we can reverse the order of the stack? We can do so by maintaining a stack, right? We can do so by maintaining a stack. And how maintaining a stack? We notice that a 3 should come over here, but 3 can't come because of the tree. So I would put a 3 in the stack, then comes my 4, then I would put a 4 over there in the stack, then I would put a 5 in the stack, right? Then I would put a 6 in the stack. Now as soon as I encounter a t, I will append all those elements. I will oppose or append all those elements into my final string, and I would continue with the I, right? So, and what would be the time complexity for this problem? I can say the time complexity for this problem would be big O of n, right? Why big O of n? Because we are just iterating only all single elements once, right? And we are just emptying stack at a point. No, not such an issue, right? So let's code the solution as well, and I will show you. So here's my coded solution. So what I have done is I have created a stack for integers, right, to store these numbers. And what I do is I create a string builder to create my final string. So I initialize my initial value is 1 by 1 because we have to create a small lexicographically smallest value, right? Then what I do, I will push the value in the stack, right? I will push the value in the stack and increase the counter. So so what happens is if it encounters a I, then empty the whole stack, and append into the string. That's what I'm doing. If my pointer reaches the end of the string, right? If my pointer reaches the end of string, you would notice I'm doing it plus 1 time, right? So that my pointer reaches so my this pointer reaches till end of this part, right? So if my pointer has reached all the string, then I have to obviously empty all the elements into the final string. Or if the character is I, then empty the whole stack, otherwise keep pushing the character. What happens in the d case? Because of the d case, because it doesn't d case doesn't go into this if part, my answer values keep appending into this stack, and then elements are just appending into the answer, and then finally I'm returning the answer. I also ran this code and it says accepted. You can see over here. I hope you got the solution. I hope you got the concept. The question is not quite intuitive for the stack approach. Let me know in the comment section if you have a doubt, and have a good day. Bye bye.